This is TMUA 2021, Paper 1, Question 19. We're told that the equation sine squared times 4 to the power of cos theta times 60 degrees equals 3/4 has exactly 3 solutions on the range of theta being less than or equal to x and bigger than or equal to 0. We need to work out a possible range that x could be such that this thing holds. So let's try and maybe work out the solutions for this equation. How might we do that? Well, first, let's just try and simplify this middle bit by, let's say, making a substitution. Z equals 4 to the cos theta times 60. And now we're trying to solve sine squared z is equal to 3/4. And square rooting this, we get that sine z is plus or minus root 3 over 2. So what solutions could z take? What is the solutions for this? Well, let's first draw sine of z, and we get something like this. And then plus or minus root 3 over 2, I've pointed on the red dots. So we need to work out what the x coordinates are of all of these points. Well, for this one, this is 60 degrees, which you should know. And then by symmetry, we know that this point will be 120, this point will be 240, and this point will be 300. So how does this generalize for an infinite range? Well, that means that sine z, or z, which is exactly 4 to the power of cos theta times 60, is precisely 60, 120, 240, or 300, and integer multiples of 360 for all of these cases. So what can we do from here? Well, we have a 60 here, and every single term on the right-hand side is also divisible by 60. So let's divide through by that, which leaves us with 4 to the cos theta must be either 1 plus 6n, 2 plus 6n, 4 plus 6n, or 5 plus 6n for n an integer. Well, what restrictions can we make on this, or what values of n must we make? Well, because cos theta is between 1 and minus 1, where must 4 to the power of cos theta lie in? Well, it's precisely between 4 and 1/4. Therefore, the only values of this that work are 1, 2, or 4. Okay, so we're trying to solve 4 to the cos theta is equal to 1, 2, or 4. Well, what values of cos theta is that? That's precisely when cos theta is equal to 0, 1, or a half. So what values of theta could this tell? Well, let's sketch the curve of cos theta. Remember what we're trying to show in this question. We know that this equation thus has 3 solutions in the interval theta being between x and 0. So our question is, which interval of this does this have 3 solutions? So let's work left to right. So immediately at 0, we have a root. And then moving on, we have cos theta equals a half somewhere here. So that gives us 2 solutions. And then when we get to 90, we get cos theta is equal to 1. So we have 3 roots already for up till 90. So we know x must be bigger than or equal to 90. Otherwise, if x was less than this, we would only have 2 solutions. So now continuing on, moving on to the right, we have no more solutions until we reach 270 when we get a 4th solution. So if x is anywhere between 270 and 90, these are the only 3 solutions of theta. And if x is bigger than 270, we have 4 solutions. So our interval must precisely be x between 270 and 90, and so our answer is